काय होते सर इथे.
Bapu sir, good afternoon.
दोन तीन मिनिटं जरा वाट पाहूया, जॉईन होत आहेत सगळे. पहिला सेशन संपल्यानंतर पवार मॅडम जरा सावंत मॅडमला वगैरे फोन करताय.
हा सर करते.
भिसे सरांना करतो, जॉईन झाले तर म्हणजे कसं होतंय. दोन सेशन आहेत. काय होते, फोन केला ना नेट जाते. लेफ्ट व्हायचे काम नाही. हा कोकाटे सर काय म्हणताय?
चुकून रेज हँड झाला असेल.
हो हो चुकून झालं.
चुकून होतं ना, मोबाईलवरून जॉईन केलं की एखाद्या वेळेस होतं तसं.
होय. चालेल बघूया. सावंत मॅडम पण आता जॉईन झाल्या होत्या बहुतेक. आमच्या डिपार्टमेंटलाही आता नेट अवेलेबल नाहीये, त्यामुळं माझ्या इथून फोन केला की नेटवर्क कट होत आहे.
हा जॉईन झालेले आहेत मॅडम.
हो झाले. सावंत मॅडम सुरू करूयात का?
सर काय होतंय, माझं सारखं ते कनेक्शन जात आहे, त्याच्यामुळे मी सारखं लेफ्ट
होय
होते.
आलं लक्षात.
हा
हा त्याच आता भिसे सरांना फोन केला होता, काय उचलला नाही त्याने बहुतेक.
गुड आफ्टरनून सर, शिंदे सर.
गुड आफ्टरनून मॅडम, गुड आफ्टरनून.
ओके ठीक आहे. कोणाला फोन करता येत असेल तर फोन करून हे करा, म्हणजे मोबाईलवरचं जर कनेक्शन जात नसेल तर भिसे सरांना म्हणजे मग चालू करूयात.
माझं काय झालंय, माझं लॅपटॉपला लिंकच येईना म्हणून मी
मोबाईलला
मोबाईलवर जॉईन झाले परत, आणि
नाही, मी
फोनाला काय
डिपार्टमेंटला
जात
केलं.
नाही.
हा नाही, डिपार्टमेंटला आता आपलं वायसीचं नेट चालू नाही ना, मोबाईलचं चालू केलंय. पण ते हे होणार. शुभांगी
सगळीकडे तेच आहे सर, मी पण मोबाईलचा हॉटस्पॉट घेऊन जॉईन केलेला आहे.
नाही, म्हणून शक्यतो काय हे चालू असताना मेसेजेस हे करतो, डायरेक्ट फोन केला की कनेक्शन कट होतं ना,
डिस्कनेक्ट होतोय. हो हो हो.
डिस्कनेक्ट होते, त्यामुळे ते हे होत नाही. ठीक आहे. सावंत मॅडम करूया सुरू. वागळे मॅडम सुरू करा.
Okay. Good afternoon, everyone. And welcome once again in the second session of FTP program. Now I request once again to the Chavan sir to introduce second speaker, Dr. B.B. Shinte sir.
Okay. Good afternoon, one and all. Today we have started the discipline-specific faculty development program for revised syllabus of MSc 1 semester 1. As per guideline of Honorable Principal Dr. B.T. Jadhav sir, for the revision of the syllabus faculty development program, definitely encourage us how to take the new part in our curriculum and how we will teach effectively in a given slot of our theory as well as practical. In the first session, today, Professor Dr. S.D. Delkar sir have explained nicely the MCT 101 inorganic chemistry, MCT 103 physical chemistry, as well as MCP 105 lab 1 practical course. Sir has explained physical and inorganic practicals. Now in the second session, today we have with us Dr. B.B. Shinte sir, Associate Professor, Department of Chemistry, Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad. First of all, I heartily welcome sir on behalf of Department of Chemistry, Faculty Development Program, as well as Yashwantharao Chavan Institute of Science, Satara. I briefly introduce Honorable Dr. Bapu Shinte sir. Sir having a very good academic as well as a research biodata, it is very difficult to explain very briefly. Sir having MSc, SETNET, GRF, PhD as well as B.Ed. Sir has completed PhD from Organic Chemistry, Synthesis Division, NCL Pune. Sir having almost 20 years research experience as well as 13-year teaching experience. The research area of Sir is synthesis of biological active compounds as well as new synthetic methodologies. Sir has delivered almost 75 invited talk at international as well as national level. Sir also worked as a resource person in various refresher orientation course as well as faculty development programs, more than 30. And sir has delivered more than 80 guest lectures in almost all universities, not only in Maharashtra, but also out of Maharashtra, sir having delivered guest lectures. Also, sir having chaired the sessions at seminar as well as conference level, more than 20. Sir is a BOS in chemistry member in SRTM Nanded, Vice Institute of Science, KBP College of Washi, then Shahu College Latur, YCMU Nashik, MGM University Aurangabad, as well as New Arts, Commerce and Science College Ahmednagar. In the research guidance, sir has, under his able guidance, 6 students have awarded PhD degree, 1 is submitted the thesis, and 3 are working in his guidance. Sir has awarded different awards. Few of them I will quote over here. Sir has received recently Global Teaching Excellence Award 2020, Best Chemistry Professor in the Year. Sir has awarded ISCB Best Teacher Award 2018 by Indian Society of Chemists and Biologists, Lucknow. Bantam Ambassador in 2018-19 as well as 2021. That is Bentham Science Publisher. Research Professor Award by Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad. Ideal Teacher Award in 2014. Sir also received Indo-US Research Fellowship Award in 2013 by IU SSTF. Then in 2012, Shikshan Pratibha Puraskar by Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad. Sir also work as a editor and guest editor, reviewer to the various journals. Few of them are mini review in medicinal chemistry, later in organic chemistry, current green chemistry, current catalysis, organic chemistry, Journal of New Development in Chemistry, as well as International Research Journal of Pure and Applied Chemistry and International Journal of Chemical Research. Sir also reviewer of more than 50 journals, Natural Scientific Report Journal of Medicinal Chemistry, European Journal of Medicinal Chemistry, Sonochemistry, Chinese Journal of Chemistry, Bioorganic Chemistry, Synthetic Communication, Medicinal Chemistry Research, Current Organic Chemistry, etc. Sir have published more than 100 research articles in international level. Sir having the citation 3025, H index 31, I10 index 79, and sir having chemical review paper which having an impact factor above 60. So such a dynamic scientist as well as academician is with us and is a member of BOS. Really, sir, having a very essential as well as new technological efforts sir has been taken in research as well as academic, and sir has always contribute his work among our college or as well as our department. So YC or even chemistry department is the second home, we can say that, of Bapu Shinkte sir, and such a dynamic person is with us. So with this brief introduction, sir discuss with us of DCT 102 organic chemistry as well as MCT 102 organic chemistry, MCT 104 analytical chemistry, and practical MCT 106 which include organic as well as analytical chemistry. So I hand over to Dr. Bapu Shinkte sir. Thank you one and all.
Thank you, sir. Good afternoon to one and all. It's a great pleasure and honor to me to be a part of this faculty development program. Am I audible properly?
Yes, sir.
Yeah. Just I will increase the volume of my laptop. Just 1 minute. Yeah. Respected Dr. Sawant Madam, Chairman, BOS in Chemistry, Yashwantrao Chauhan Institute of Science, Satara. Head, Dr. Bhise Sir, Department of Chemistry. BOS members in Chemistry from YC Institute of Science, Satara. And my dear colleagues, faculty members from Department of Chemistry. Thank you very much for giving me an opportunity to share my views regarding just prepared the syllabus of MSc first semester. I want to clarify one thing, Chauhan sir. I am not a scientist. I am the learner of organic chemistry, especially. I am not a scientist. I am the learner of organic chemistry. And yeah, you have rightly mentioned that Rayat Shikshan Sanstha is my second home, definitely, because in every week I am talking with the Rayat peoples. See, within this week, on Monday, I have discussed chemistry at your college, Anna Sahib Aute Mahavidyalaya Manchar, and this Saturday means weekend. Again, I am talking with Rayat Shikshan Sanstha's YC Institute of Science, Satara. No doubt, it's a difficult task for me to share my views regarding the syllabus prepared by all of us, definitely. And this syllabus is as per the UGC guidelines, and we are following the choice-based credit and grading system. Yeah, after getting the autonomous to YC Institute of Science, Satara, from first day, I'm witnessing these particular moments, even though the day which the proposal of autonomous status was submitted to the university, I was there. And when it was forwarded to the government of Maharashtra, again that day I was there. And from first meeting of BOS in chemistry till date, I am totally involved in the in your institution, no doubt. As I said that we have prepared the syllabus as per the choice-based credit and grading system, and so many other our senior colleagues, senior faculty members from all over the India, like Professor Maulikar sir, Pardeshi sir, Dr. Delekar sir, and some of the faculty members from I think Karad College and some industry representative and one of the member from NCL Pune also was involved in the designing and development of this new curriculum, and we have made corrections in earlier curriculum, no doubt. And we have compared this syllabus with the syllabus of Shivaji University parent institution. We have to compare that one. Okay, definitely the syllabus is made by as per the outcome based education system, that is OBE, outcome based education, because this is a needed as per the new norms of NAC. They are asking our curriculum as per the outcome based education. Definitely we all have prepared learning outcomes for each and every course. I'm saying each and every course, no doubt. Later on, we have prepared program outcomes also. Okay, based on whatever courses are there. And see, in these courses, I want to discuss one of the things, because from last 13 years, I am also involved in the modifications of the syllabus of our university. See, in the last 13 years, we have modified our syllabus 7 times. And the net output of modification of such a syllabus in terms of getting qualifying in the competitive examinations like NET, SET and GATE, as well as students are getting the opportunity to work in some of the pharmaceutical industries with the help of such modified syllabus. They are getting such kinds of job. That is one of the criteria in modification in the syllabus. Then second one, if we are modifying the syllabus as per the developments made by the researchers and their outcome in the form of this theoretical part, theoretical as well as practical chemistry. See, from last 1.5 years, we have witnessed that this COVID-19 pandemic, and from very first day we are listening about the antiviral agents. Even though we can incorporate these antiviral agents in the curriculum of MSc second year, definitely in due course. No doubt, those who have not studied a single standard, even though they didn't went to the school, then also these people know about the drug, that is a remdesivir. Remdesivir, dexamethasone, whatever drugs prescribed for the patients of coronavirus, as well as in the last year, 2020, in the month of April, May, June, we have listened about the chloroquine, hydroxychloroquine. These 2 drugs were prescribed for curing this coronavirus. And accordingly, we have also studied, we have also witnessed that how to make vaccines also. And definitely our second year students, they may get experience of such kind of drugs, how those drugs are synthesized. Definitely such type of syllabus we can incorporate in our MSc second year in future. Now coming towards the point, as I said that our syllabus is made as per the new guidelines. Definitely after 2 years again we have to modify our syllabus, because the new education policy will come in the year of 2022. Again we have to do such kind of modifications. Okay. Now I will share my presentation, whatever syllabus is there, and everyone have gone through the syllabus definitely, because we all of us have prepared that particular syllabus. Just please, I will share my presentation. I think it is visible for you. Chavan sir.
Yes, sir.
Yeah. Okay. The paper number MCT 102 Organic Chemistry. Just 1 minute. Some updates are coming to my laptop. as we know very well, the learning objectives for the paper number 102, organic chemistry. Uh, See, in this particular paper, the students are learning the fundamentals of organic chemistry. No doubt in BSc first, second, and third, they have studied so many things. And just with the help of that knowledge, they have to apply again some advanced techniques in organic chemistry, especially the reaction intermediates, reactive intermediates, how those reaction intermediates are generated, how these can be used for many reactions. It means that students should learn how those reaction intermediates can be generated, can be utilized, and their stability as well. And students should know about the mechanism related to different types of substitution reactions, no doubt aliphatic and nucleophilic substitution reactions. And also they have to learn the mechanisms for various types of elimination reaction. And the most important factor is that they have to learn the basic concepts in stereochemistry, which they have studied in BSc as well. Okay, as we know very well, the chapter-wise curriculum for paper number 102 of organic chemistry, it has been divided into 4 units, and the first unit is dedicated to reaction mechanism, structure, and reactivity. And I used to see this particular topic at every universities of India. Okay, because once the student should understand the fundamentals of organic chemistry, the Lewis structure of organic compound, then acidity, basicity, acids, base, Lewis acid, base concept, then only they can understand organic chemistry very well. And the first chapter is dedicated to that particular kinds of reaction intermediates, like how to understand chemical bond, delocalization of pi electrons, how the conjugation effects plays an important role, resonance, hyperconjugation, atomerism, inductive effects, means how these effects, and to understand these particular effects, what kind of fundamentals is required, and they have to learn from this particular topic. And later on, as I said, that acidity and basicity. Okay, and most important topic is aromaticity, and students should learn what is meant by aromaticity, what are the rules and regulations for the determination of aromatic nature, non-aromatic and anti-aromatic nature of organic compounds. It may be plain aromatic compound or it may be heterocyclic compounds as well. And these things students should know with the help of aromaticity. They have to know about the Huckel's rules and different kinds of parameters for determination of aromatic nature. Then these aromaticity rules, they have to learn for carbocyclic, as I said, that heterocyclic compounds, annulenes, azulines, tropylium cations, metallocines as well. No doubt, even though after understanding of this particular topic, they have to solve different types of problems. Even though whatever reference books we have prescribed over here, after completion of each and every topic, they have to solve the exercise given at the end of each section. End of each section, that is important. And we, the teachers, should ask question like that way, because the pattern of question paper has been totally changed. In earlier days, we have to ask the questions like descriptive type of questions. But now, because of this COVID-19 pandemic, we have to draw the question paper in the form of multiple choice questions, and this concept may be forever in future, definitely. That's why we have to prepare multiple choice questions based on such type of topics, and we have to give some assignments of the students. Then only the interest will increase in such type of organic chemistry papers. Many times it has been observed that in question paper of organic chemistry without structures, then how that question paper is organic chemistry question paper. If we are asking the question, write Huckel's rule, okay, or explain Huckel's rule. No, it should not be like that way. How Huckel's rule can be applied for the determination of aromatic, anti-aromatic and non-aromatic nature of following compounds. And what could be the reason behind that one? Like that way, we have to raise the questions. Then, as I said, that how to generate the reaction intermediates, that is carbene, nitrines, carbocations, carbanions, and different types of free radicals, their generation as well as their stability. Okay, how carbocations are generated, how carbanions are generated, and where these reaction intermediates can be used. Just representative examples which we can provide to them. Not only from single substrate, but also you can use different types of substrates for the generation of these carbenes, carbocations, carbanions as well. And this is the first topic, which is a fundamental of organic chemistry. It is related to fundamentals of organic chemistry. Yes. If you have any queries regarding this particular topic, then I am always ready to discuss with you peoples. Because I can't see your faces over here because our meeting is through Google Meet. Yeah, if you have any queries, you can ask me. Otherwise, we will go for our second chapter. Chavan sir. Hello? Hello? आवाज येतोय का?
Yes, sir. Yes, sir.
Yes.
Sir, I have one question.
Yes.
In the explanation of that carbene nitrine,
Yes.
whenever we involve in the insertion type of reaction of that carbene and nitrine,
Yes.
is
Yes.
there a explanation for the stereochemistry into that?
Yeah.
Include the
Definitely. Yes, sir. Yeah, very nice question. And see, just I want to put before you. There was one question in the NET examination for 2019, I think so. 2019. They have given some allylic alcohols and some carbene is there, and that allylic alcohol is means disubstituted. Means it is a substituted allylic alcohol was there, and after insertion of that carbene, what kind of stereochemistry it will form, whether cis or trans type, that protons, it depends upon what kind of alkenes you have considered over there. Means you can explain in short, because this is the fundamental topic, and once they can understand, then they can further understand whatever the reactions are there. For example, Simon-Smith reaction. If you want to teach Simon-Smith reaction in future, under the heading of organogen compounds, and carbene is there, formation of carbene, and how that carbene can react with any kind of alkenes. In short, here you can use some explanation. It always forms cis type of product. It always forms cis type of product. Not only for carbenes, but also carbocations. Even though we are generating carbocations, and you have to discuss the stability of carbocations as well. No doubt, in fact, we are saying that a tertiary carbocation is more stable than secondary than primary, but it varies from example to example. It varies from example to example. There may be some benzylic carbocation may be there. There may be some allylic carbocation may be there. And what kind of examples are there? Accordingly, we have to discuss. Yes, so it's a good question, sir. आपल्याला सांगायला किती वेळ लागेल? It may take just 10 to 15 minutes, but it will increase the interest of the students definitely. Otherwise, for understanding of organic chemistry, it looks very much difficult. म्हणजे प्रत्येक विद्यार्थी असा सांगतोय की सर आम्हाला क्लासमध्ये ऑर्गॅनिक केमिस्ट्री समजते, पण जेव्हा परीक्षा येते परीक्षेच्या दिवशी सगळं कन्फ्युजन होतं, बिकॉज they have prepared organic chemistry by means of memorization, not understanding. Okay, understanding of the subject is important. Yes, sir.
Yes, sir. Yes.
Yeah, is there any
Thank
answer?
you.
Yes. Shall I move forward?
Yes, sir.
Yeah, okay. Because it's a basic topic. Yeah, and the most important topic, even though the students have studied this particular topic in BSc, then also we have included this particular topic for MSc first semester again. The title is the same, definitely, maybe same. Whatever title in BSc, the same title is there. But the level of teaching and understanding should be more. Okay. Whatever the syllabus is there, whatever points are there, these points should be applicable for complicated examples. Like see, even though they have already studied SN1, SN2, SNI type of reactions, no doubt, but along with some stereochemical aspects also. Even though the students, those who are studying for MSc program, they don't know the difference between electrophile and nucleophile. Okay, and first of all, we have to clear that point. Which one is electrophile and which one is a nucleophile? If you give the example of carbanion and carbocation, okay, you can compare with electrophile and nucleophile. Okay, at that time, see, if students don't know electrophile and nucleophile, and how they will study nucleophilic substitution reaction or electrophilic substitution reaction. That's why fundamentals of organic chemistry should be clear first. And take the examples of related like allylic system, aliphatic trigonal, benzylic, aryl and vinylic carbons type of systems you have to consider over here. Okay, not only direct aryl in aryl case means it should be benzylic type of system. Benzylic type of system which produces carbocation. That type of systems we have to take for SN1, SN2 and SNI type of reaction. Okay, again, students should know about different types of nucleophiles. Okay, most of the times which we are discussing, water is the nucleophile or hydroxide is the nucleophile. Okay, for understanding of SN1 or SN2 reaction, yes, you have to change different types of nucleophiles over here. That's why types of nucleophiles is also important. Types of nucleophiles or types of that leaving groups also. Nature of leaving group, nature of nucleophiles. No doubt they have to learn ambidextrous nucleophile as well. And see, even though which type of reaction is more favorable, it also depends upon what kind of nucleophile we have used and what kind of electrophile is there. If you have teach this particular point, if sterically hindered leaving group is there and non-sterically hindered leaving group is there, and you have used same kind of nucleophile, then either SN1 reaction takes place or SN2 reaction takes place. Okay, and definitely we have to teach that point, and that point should reach in comparison with elimination type of reactions. Later on, we will discuss substitution versus elimination reaction. Okay, no doubt at the end of this particular point, students should learn what do you mean by neighboring group participation, that is unchimeric assistance also, because many times at least one question in the NET and SET examination they are asking this NGP or unchimeric assistance. That's why our target should be fixed. Students should know this particular point, and these points once they clear, then they can understand organic chemistry very well. Any doubts in this first part of substitution reactions, aliphatic nucleophilic?
सर एनजीपी पार्टिसिपेशन जे आहे त्याच्यामध्ये किती एक्झाम्पल घेणं अपेक्षित आहे?
यस, हा क्वेश्चन मला वाटलंच होतं येईलच, कारण हा एनजीपी कन्सेप्ट लेटर ऑन वी आर नॉट डिस्कसिंग. दॅट्स वाय यू हॅव टू टेक मेनी मोर एक्झाम्पल्स. मला काय म्हणायचं की 10 एक्झाम्पल घ्यायला जर तुम्हाला 20 मिनिट लागत असतील तर नंतरचे 5 एक्झाम्पल घेण्यासाठी 5 मिनिट लागतील. अदरवाइज यू हॅव टू गिव्ह सम एक्सरसाइज टू द स्टुडंट्स. Exercise. Okay, assignment, we can give assignment to the students, but you should have a collection of that type of examples with you, and you can discuss. Once you discuss with the students, they will not forget, and you take these examples from the quality books. That is important. Quality books, neighboring group participation from quality books. Okay, there is no any limit, but if the students have understand that particular concept, then they can solve n number of problems. See, organic chemistry is a problem solving chemistry, and if you are doing that particular technique for understanding of organic chemistry through problem solving approach, then student will not forget forever. Okay, that's why many times I am saying that grindstone sharpens knives, problem solving sharpens minds. Okay, yes, ma'am.
Okay, sir.
Yeah, any other?
Sir, the SN reaction at the bridgehead carbon,
Yes.
it find very difficult when we refer the reference book. That type of example is
Yeah.
not seen in the number
Yes.
of times.
Yeah. This means substitution reactions at bridgehead carbons. Bridgehead carbons. See, you are not getting these examples. Which books you are referring, sir?
व्ही के आलूवालियामध्ये पण आहेत हे पॉइंट्स, पण त्यामध्ये शॉर्टच पॉइंट दिलेला आहे
Okay. Other book?
हा.
Okay. Just I want to tell you one thing. As we are teaching two postgraduate students, MSc first year, and we belongs to autonomous institution. This is my suggestion to all of colleague, my senior teacher also. You have to refer reference books for post-graduation program. Reference books, not a textbook. This is my suggestion to all of you. If you follow, if you go through the books written by the great teachers of organic chemistry like Carey Part B, or Organic Chemistry by M.B. Smith. Okay, Organic Chemistry by M.B. Smith, or you can have a Claydon book, Organic Chemistry by Claydon Warren. That book. Definitely, you may get some of the reason behind that one. Why this nucleophilic substitution reaction is less favorable on bridgehead carbons. Okay, my suggestion to all of my colleagues, senior teachers as well, you have to refer the quality books, not a textbook. This Ahluwalia, I can consider this book student can refer of BSc first year. BSc first year students should refer this Ahluwalia book. This is my suggestion. Okay.
Sir, we are also using Claydon.
But I want to tell you story behind Claydon. Story behind Claydon. See, this book was prepared by the Claydon and Warren, great teachers. They are the great teachers. Just Warren passed away in the last year only. They are the great teachers, and they have prepared that book for undergraduate students. And in Maharashtra, in India, we are referring that book for post-graduation. See, and that Claydon's book looks like a textbook, textbook. If you follow this Miss Organic Chemistry, Jerry March, then Carey Part B, and many more books are there. Definitely you are following. And students are saying that, sir, it's difficult to understand the chemistry from Jerry March, Precise, Claydon, Carey, this one. There is no excuse because students should learn original organic chemistry and in details, not in shortcut way.
Okay, thank you, sir.
Okay, sir. Okay, sir. Thank you, sir.
This is my suggestion to all of you. Then aromatic electrophilic substitution reactions, and very much important topic in aromatic chemistry. Very much important topic. If students should learn aromatic chemistry, they have to know first this point. That is electrophilic substitution reaction. No doubt they have already studied what do you mean by electrophile, nucleophile. How to generate electrophiles, that is also important, means they should know about the Lewis acids or acids, different types of acids, how they can be used for the generation of electrophiles. The electrophile may be carbon based, it may be nitrogen based, it may be sulfur based, or it may be halogen based. And how the acids are used for the generation of that electrophiles. it may be nitro group, it may be that sulfonic acid, that is electrophile, or it may be sulfur trioxide in Friedel-Crafts alkylation, acylation. How electrophiles are generated in alkylation and acylation reaction, alkyl halides, alcohols, then alkenes, how can be used as an electrophile in Friedel-Crafts alkylation reaction, as well as in acylation, like acid chloride, acid anhydrides, as well as acids directly. That is organic acids, how they can be used for Friedel-Crafts acylation reaction. Okay. First of all, students should know how aromatic compounds gives electrophilic substitution reactions. How aromatic compounds, plain benzenoid based aromatic compounds, and then heterocyclic based aromatic compounds also, like furan, pyrrole, thiophene, then pyridine, quinoline, isoquinoline, such type of heterocyclic compounds, how they give electrophilic substitution reaction, and what is the orientation of attacking of electrophile. See, orientation of attacking electrophile on different types of aromatic substrates. The aromatic substrates may be electron donating group or it may be electron withdrawing group, and how these groups are ortho-para directing in nature. Ortho-para directing in nature or meta-directing in nature. See, I want to tell you, students don't know, even though they have completed their master program, what is the difference between donating group and withdrawing group. What is the difference between electron donating group and withdrawing group, or how the directing nature of those groups can be determined. What are the criteria should be there. Okay, like that way, we have to transfer this knowledge to the students. No doubt, later on we have to discuss what kind of ortho-para ratio is there, and you have to consider many more examples in the discussion of ortho-para ratio. It depends upon the electrophile, it depends on the substrates, it depends also on the temperature, plays an important role, as well as the solvent also. And then you have to discuss then another type of substitution reaction, that is ipso substitution reaction. Ipso substitution reactions, and we have to give this particular concept to the students. What is the difference between electrophilic substitution versus ipso substitution reaction? Means difference between electrophilic substitution versus ipso substitution, and what are the criteria for ipso substitution reactions. Okay, no doubt we have already studied concepts of aromaticity. Again, there is no need to discuss this concept of aromaticity over here. And as I said, that orientation in their ring systems, then diazocoupling, how diazonium salt formation takes place, as well as the applications of that diazonium salt for preparation of different types of organic compounds. Then we have to give the mechanism used for introduction of formyl group by means of Wilsberg formulation reaction. How DMF and POCl3 gives that particular intermediate, and how that intermediate can be used for the incorporation of formyl group. And finally, this somewhat a different type of reaction. It is not a actually electrophilic substitution reaction, von Richter rearrangement. It is not an electrophilic substitution reaction. It is the example of nucleophilic substitution reaction, we can say. It is not an electrophilic substitution, but I don't know, it may have been incorporated in this particular topic. But if you want to teach this von Richter reaction, then you have to take the example of nitrobenzene, substituted nitrobenzenes, and reaction with sodium cyanide, then followed by some reactions will be there, and formation of corresponding acid. That is the von Richter rearrangement or von Richter reaction is there. Yeah, if you have any doubts, you can discuss with me, because this is my favorite topic. And while teaching this particular topic, I am discussing a lot how to select solvent for any kind of organic reaction. Solvent plays an important role in organic reactions as well. And we have to teach why nitrobenzene is chosen for Friedel-Crafts acylation or alkylation reaction. Why not other solvents also? And it may take some half an hour, no doubt, but students may get benefited after discussion of different types of solvents also over here. Yeah. कोणाला काय विचारायचं?
Hello, sir.
हा.
in the Friedel-Crafts reaction, that is alkylation and acylation, is there is a teach to student that is the limitation of the Friedel-Crafts alkylation. That's why we prefer for the acylation. That is the advantage.
Good point. See, how to overcome the limitations of Friedel-Crafts alkylation reaction by means of acylation and followed by reduction. Yeah. But you should not tell like that way. Huh? See, there are some limitations of Friedel-Crafts alkylation, and whatever limitations are there, we have to teach them first, like isomerization, randomization. Okay. Then if the substrates are having some electron withdrawing group, then further electrophilic is not possible. Like that way. No? And see, these kinds of points, after discussion of these points, if you want to introduce some long chain alkyl group, then Friedel-Crafts alkylation is not a suitable reaction. And if you want to introduce that long chain alkyl group, first you have to do Friedel-Crafts acylation, followed by if the students may have studied Clemmensen reduction or Wolff-Kishner reduction, we can discuss that point also. See, over here, we can teach students how naphthalene can be prepared with the help of Friedel-Crafts acylation reaction. Okay, how tetralone can be prepared. That example one can take. How tetralone can be prepared through Friedel-Crafts acylation reaction. Okay, by using some benzene and succinic anhydride followed by reduction and then cyclization reaction. Means even though we can teach to the students intramolecular Friedel-Crafts reaction, intramolecular, no doubt we are teaching intramolecular Friedel-Crafts reaction, but also we can teach them Friedel-Crafts, intramolecular Friedel-Crafts alkylation as well as acylation reaction.
Okay, sir. Okay.
आणखीन काय?
वाघमारे मॅडम.
नो सर.
या डायझो कपलिंग मध्ये किती एक्झाम्पल घ्यायचे हा पण प्रश्न असू शकतो बरं का. आय कॅन अंडरस्टँड. You can take at least 3 to 4 die-formation reaction. That is usually we are teaching to the students like beta-naphthalene NaOH, trapping of that diazolam salt with beta-naphthalene NaOH. Then you can take aniline dimethyl aniline also. You can take aniline example or some other kinds of examples also. Okay, for teaching this diazolam reaction.
Okay, sir.
Okay, sir.
Yeah, then next unit, no doubt it's a huge syllabus. No doubt it's a difficult to teach within the stipulated time, but then also we have to take some extra efforts also. Okay, addition reaction. This is a very much important topic in organic chemistry. Because once they understand this addition, substitution type of reactions and elimination reactions, they can understand further organic chemistry. And if students don't know the fundamentals of this one, then they are unable to learn organic chemistry very well. No doubt, in addition reactions, what kind of mechanism is involved, as well as stereochemistry by taking different types of electrophiles, nucleophiles. Okay, what type of selectivity is there? That is a chemo-regio selectivity, and accordingly, we have to consider this particular point. No doubt, there is no limit in addition type of reactions. There is no any limit. But most of the points, means maximum points, one has to consider in addition reaction. Okay, means not only to alkenes but also alkynes. Not only by considering the addition of water, addition of bromine, or addition of HBr, not only these, but also one has to consider how how these alkenes are reacted with some paracids also, how that alkenes are converted into alcohols. You can teach these points to the students, means hydroboration reaction, oxymercuration, demercuration reaction through Markovnikov rule and Markovnikov rule, because they have to learn over here. And while doing these addition reactions, we have to we have to teach these points to the students. Then again, if the students are studying substitution reaction, they have to learn elimination type of reactions as well. Okay, without eliminations, the topic could not be completed. That's why, as I told you, that substitution versus elimination reaction. And it depends upon what kind of nucleophiles you have used and what kind of leaving groups we have considered for this aliphatic nucleophilic substitution reactions. And that's why, first of all, we have to give the types of elimination reaction, that is E1, E2, E1, CB. These examples, E1, E2, E1, CB, at least 2 to 3 examples we can discuss over here, and what kind of mechanism takes place over here. Then most important point is orientation in elimination reaction. What kind of substrate and what kind of product you will get later on. And the most important 2 types of eliminations, basic elimination, that is Hofmann elimination and Satzef elimination. These 2 eliminations are very much important. And what could be the respective products, means either more substituted or less substituted. Why more substituted is favored by means of Satzef, and why less substituted is favored by means of Hofmann, and what are the criteria for Hofmann and for Satzef elimination reaction. Then we have to discuss the most important point, that is pyrolytic syn elimination also, by considering the examples of acetate. Okay, how acetate, at the last point, pyrolysis of acetate. Yeah, that is the example of pyrolytic syn elimination reaction. Pyrolysis of acetate as well as xanthates. How xanthates can be converted into alkenes by using Tsugev reaction. And that is the most important reaction in organic chemistry. Yeah, any doubts again? Hello? Because
No, sir.
these are the very much important. See, later on students may learn Peterson elimination also, no doubt, Peterson elimination reaction, because these are some basic topics of organic chemistry. Okay. Yeah, there are
Okay.
some corrections are there, no doubt. Some spelling mistakes are also there. Some typographical corrections is there, and definitely when we modify the syllabus next year, then we can make these corrections also. Okay.
Okay, sir.
Okay, sir.
As a co-elimination reaction is also there, which is the remaining. Then most important, see, nowadays in net examination especially, they are asking the product along with stereochemistry, and definitely our students have studied fundamentals of stereochemistry in BSc, and just extension of that stereochemistry topic over here, and different subtopics are there related to stereochemical outcome of the reaction. First of all, they should know about why we are saying that the molecules are having some chiral centers. Means here they have to learn the basics of stereochemistry, like enantiomers, that is stereogenic center. Stereogenic center, first of all, then enantiomers, diastereomers, epimers, how enantiomeric excess, that point maybe come later on. Definitely, at the last it is given. What is the difference between enantiomers and diastereomers as well as epimers? Okay, mesoforms, how to draw it, and how to determine the configuration of the molecule by providing some structure, chiral compounds, and how IUPAC name for that compound can be given. Okay, no one is asking IUPAC name of those compounds, just we are asking to the students what is the configuration of this particular compound, either R or S, okay, or E or J. It's a very simple job of 12th standard, because in 12th standard stereochemistry is also there. But if you ask some IUPAC name of small chiral compounds, if we discuss that point, because students definitely may have studied in 11th and 12th standard, again they can apply that particular knowledge in the giving nomenclature for the particular compounds. Not only this one, but also they have to know the chirality in case of axial and planar chirality, principles of axial and planar chirality, prochirality. What do you mean by prochiral centers? That is also important, and different homotopic, heterotopic, and distereotopic ligands and phases also. And then, as I said, that nomenclature of stereo heterotopic ligands and phases, symbols, they have to learn, and how to introduce some chiral center in the prochiral compounds. That point, because this topic is a basic stereochemistry topic. Definitely later on students may learn the stability of chiral compounds by considering disubstituted cyclohexane system. It may be 1, 2, 1, 3, 1, 4 disubstituted cyclohexanes. It may be cis, it may be trans, axial, equatorial, and how to determine the stability of those compounds they can learn over here. Yeah, if you have anything, I'm ready to discuss over here. As you all are expert in this one, in this topic, no doubt, but if you have any queries, we can discuss. Yes.
Sir, it is for that is whenever we teach the unit 1st to 4, we can start the unit 1st and unit 4th first, and then we go for the addition and elimination and electrophilic nucleophilic substitution reaction.
Yeah. Very nice question. Because if we are teaching aliphatic nucleophilic substitution reaction, and if we have considered some chiral compound for nucleophilic substitution reaction, then students are unable to understand. If as we are saying that racemization takes place, inversion of configuration takes place, and if students don't know these concepts, then it becomes very much difficult. That's why one has to follow some sequence. मी असं कधीच करत नाही, ज्या गोष्टीची गरज अगोदर आहे ती गोष्ट मी अगोदर शिकवतो आणि नंतर मग इव्हन दो असं कधीच आपण पीजी ला करायचं नाही की पहिलं युनिट संपल्याशिवाय दुसऱ्याला दुसरं झाल्याशिवाय तिसरं झाल्याशिवाय चौथ्याला, असं नाही. Whenever that point is required, accordingly we have to discuss it. इलिमिनेशन रिएक्शन शिकवायचं आपल्याला. इलिमिनेशन मग कायरल तुमचा एखादा कंपाऊंड घेतलेला आहे आणि त्या मुलाला कायरलिटी कशी असते हेच माहिती नाही आणि आपण तिथं सांगतोय की येणारा अल्किन हा ई अल्किन आहे किंवा झेड अल्किन आहे आपण सांगतो, ते केव्हा त्या मुलांना स्टडीड स्टेरियोकेमिस्ट्री फर्स्ट. Why not to start with stereochemistry first, and then you can stereochemistry and aromaticity. Sorry, that first topic, basic topic, first unit, and first unit you can start parallelly, and later on aliphatic nucleophilic substitution reaction, aromatic electrophilic substitution, and then elimination. At the last, you can teach elimination reaction.
Okay, sir. Thank you.
असं नाही की म्हणजे बऱ्याचदा प्रश्न पडतोय की पहिल्यांदा टॉपिक दिलाय म्हणून पहिल्यांदा शिकवला पाहिजे, शेवटी दिलाय म्हणून शेवटी शिकवलं पाहिजे, असं काय. ऑर्गॅनिक केमिस्ट्री इज अ डिपेंडंट केमिस्ट्री. म्हणजे आपल्याला स्टेरियोकेमिस्ट्री शिकवायचं झालं तर त्या मुलांना 11वी मध्ये पण न्यावं लागतं. बरोबर आहे?
करेक्ट सर.
येस. आणखीन काय? काय नाही?
वाघमारे मॅडम?
No, sir.
Yeah. And a huge list of reference books are given over here. Definitely some specific books, and in your library, Peter Sykes may be there. Then B.S. Gold. I don't know about the remaining books. Eli definitely, but the students are not preferring to read through Eli's. But if they want to learn stereochemistry by means of Nashipuri, this book is good. Stereochemistry of Organic Compounds by D. Nashipuri. Yeah. Then Basic Principles of Organic Chemistry. I don't know. This H.O. House book, Modern Organic Reactions. Excellent book. Even though this book can be used for understanding of practical organic chemistry. Then Principles of Organic Synthesis are also Norman Coxon. That is okay. Then Mukherjee, S.P. Singh. These are the old books. P.S. Kalsi, there is no need to use P.S. Kalsi, this book, Nashipuri book, because Nashipuri was the student of Eli. Okay, Nashipuri was the student of Eli. Okay. That's why He has written excellent book without mistakes. Definitely, I am also fan of P.S. Kalsi. I met several times. We have discussed a lot with P.S. Kalsi, no doubt. But there are some mistakes are also there. Okay, and I have not seen the book of Claydon, Carey, okay, Jerry March. Okay, in future, just Wagpare madam, you should remember me later on. We can
Okay.
incorporate these reference books in your.
Okay.
Yeah.
Okay, sir.
Keep
Jerry
books.
March is there.
Yeah, it is there. Jerry March is there. Advanced Organic Chemistry by Jerry March.
Yes, sir.
But then March Advanced Organic Chemistry by M.B. Smith. That is a good book. Okay.
Okay. Okay, sir.
आणि
Okay, we must.
बुक
Okay, sir.
आपल्याकडे
We.
नाहीत असते काढून टाकायचे सरळ सरळ काढून टाकायचे आपल्याकडे जे लायब्ररीत नाहीत आपल्या माझ्या
Okay.
माहितीनुसार तुमच्या लायब्ररीत हा 10 नंबरचा बुक आहे का नाही मला माहित नाही बेसिक प्रिन्सिपल्स ऑफ ऑर्गॅनिक केमिस्ट्री बेंजामिन इट मे बी देअर जेडी रॉबर्ट्स अँड दिस वन
Okay, sir.
it's a very simple book and yeah if you want to learn fundamentals of organic chemistry that are given sir but have many more mistakes are there.
मिस्टेक्स आहेत त्याच्यामध्ये हो.
नॉर्मल आणि कॉक्सनला सबस्टिट्यूट बुक इतके आहेत की सांगता बस आता कारण हे 20 वर्षापूर्वी नॉर्मन कॉक्सन शिवाय पर्याय नव्हता ऑर्गॅनिक सिंथेसिस शिकायचं म्हणलं तर
Okay.
20 वर्षापूर्वीची गोष्ट आहे आता त्याला क्लेडन आहे कॅरी आहे यस आणि आपले मुलं जर नेट पास व्हावेसे वाटत असेल तर दे हॅव टू रिफर सच टाइप ऑफ बुक्स.
Okay, sir.
Okay, sir.
Okay, sir.
Can you forward? Yeah, you know very well what are the learning outcome. There is no need to discuss because you all people have prepared this particular learning outcome. Discuss करण्याची आवश्यकता learning outcome and this just reading होईल. Just reading.
No, sir.
No, sir.
No,
Yeah.
no, sir.
Yeah. Okay. When difficult task to me how to discuss the syllabus of paper number MCT 104 analytical chemistry. No doubt I am not expert in this subject, but I will try my level best to discuss the syllabus of analytical chemistry. Okay. I have studied analytical chemistry, no doubt, in the form of general chemistry, and lot of work I have done on this analytical chemistry also, because some topics are basic topics. Even though whatever topic is there, first topic that is related to errors and precision, which we have studied in our MSc first year, until date that topic is there. How to minimize the errors, and students should know different types of chromatographic techniques like TLC, then paper chromatography, gas chromatography, HPLC. Means some specific chromatographic techniques are there. Then students should know fluorescence and phosphorescence, and the most important characterization techniques, that is thermal analysis, that is TGA, DTA, and DSC. Okay, these are the some learning objectives of the paper number 104 analytical chemistry. Okay, we will go one by one. The first topic is related to errors and treatment in analytical chemistry. No doubt, first of all, we have to give some definitions related to errors, determinant, constant, and indeterminate. Accuracy and precision, with the help of some examples, we can teach to the students, and how it can be minimized. Then deviations, different types of deviations, that is average deviation, standard deviation, variance, and confidence limits. Then some significance of figures and computational rules, and least square method, how it can be used, and how to do methods of sampling and techniques of sampling of gases, fluids, solids, and particulates. Okay, see, after teaching this particular topic to the students, we have to give some assignments in the form of some problems. And how to determine the standard deviation or average deviation after providing the secondary data, and how it can be applicable in research. Nowadays, lot of softwares are there. See, those who may have pursued their PhD degree in some analytical techniques, what can call it, using some software that is SPSS software. Most of these students from social sciences as well as statisticians, they are using such kind of software for software like SPSS for analyzing the data, secondary data. Okay, this is the first unit. Just 1 minute. And second unit, which is related to chromatography, definitely what are the applications of chromatography, why there is a need of different types of chromatographic techniques, that is gas chromatography, GC. What is the principle of this gas chromatography and how it can be utilized for determination of purity of the organic compounds, low volatile compounds, how this gas chromato can be used for different types of purity of the organic compounds. Then thin layer chromatography, how this can be used and how TLC can be prepared. And that time you have to teach to the students, that is a mobile phase as well as stationary phase in thin layer chromatography, because if they understand very well this TLC with the help of some practicals as well, then they can understand very well. And then column chromatography. See, if we can take example of mixture of some organic compound, it may be 90%, 10%, how that can be separated by means of column chromatography. Why there is a need of column chromatography? If the compounds are solid, then we can separate that means by means of crystallization. It may be by fractional crystallization. But if your compound is liquid, then how this column chromatography technique can be used for the separation of that minor impurity also. Okay. Then in column chromatography, again you have to teach how fractional column chromatography is there. Fractional column chromatography. Okay, and how that column can be made, what kind of material is used for the preparation of column. Okay, it may be silica of different size, it may be alumina of different size, and what kind of solvent systems can be used, polar, non-polar solvents. That's why students should know first of all the types of solvents used in column chromatography, means their polar nature of the solvents they should learn over here. Yeah. Any doubts in chromatographic techniques as well as in errors?
Sir, we have the practical, that is the organic preparation. In that we done that thin layer chromatography.
Yes, good. Not only in preparation, but also see what we are doing at our university level. We are giving students to binary mixture separation, and once they have separated and crystallized the material, then we are asking them to check the purity of the given compound. Not only in the preparation, but also while doing the separation of binary mixtures. Means at that
Binary mixture.
Yeah, at that stage only students can learn. We are not providing directly alumina sheet. They have to prepare TLC on glass plate.
Same is here.
Yeah,
Same is here.
Yeah, and for project work, just we are providing aluminum sheet to the students. That's why studying in theory is different than in practical. What kind of silica we have to take, what kind of solvent we have to take for the preparation of TLC. Okay, and why that glass plate is not a UV active. Okay, that is also important thing over here. Why aluminum we can see through UV? Why not this glass plate? Yeah, that reason.
That is detector system.
Yeah,
That is also pointing.
Material used in aluminum sheet. ओके, असा आपण इंटरेस्ट त्या मुलांमध्ये निर्माण करू शकतो. नाहीतर काय होते, प्रोजेक्टला मुलगा आला की त्याला डायरेक्टली टीएलसी घे म्हटल्यानंतर तो काय टीएलसी घेणार आहे. दॅट्स वाय फर्स्ट ऑफ ऑल दे शुड नो अबाउट दिस. Okay, column chromatography theory, it's okay. By picture we can show in the classroom, but if suppose some students of MSc second year and they are pursuing some project work and they are doing some column chromatography separation, we can show them how to prepare the column practically, because it's an easy job. There is no need of any specific equipment like in GC. It's a simple job. Just fill the column by means of silica and elute some with the help of some solvent. Then add your organic compound and elute with the help of some solvents, like that. With practical experience. Okay.
Okay, sir.
Yeah. Any doubts? जे अनार्टिकल शिकवणार आहेत ते माझ्यापेक्षा निश्चितपणे ते एक्सपर्ट आहेत. Okay, then it comes next topic, that is luminescence spectrometry. Here different techniques are there, that is a fluorometry, fluorometry and phosphometry comparison. Comparison of absorption and fluorescence methods, their theory, like this way. Okay. How these spectrometric techniques, that is fluorescence spectroscopy spectrometry is used in detection of some different types of compounds. We have to teach them, and the final unit is related to characterization techniques again, like TGA, DTA, and DSC. How these three techniques are used for the determination of some inorganic material, not only inorganic but also sometimes organic also. See, in this thermogravimetric analysis, that is TGA, what is the principal instrumentation? We can show TGA to the students also. Okay, and how this TGA is used in research also. In research, okay, we can show students one of the graph. Some of the research students, they may have taken for their analysis, and we can discuss that particular graph, that particular image to the students, and how this TGA technique is used for the determination of some decomposition, how decomposition takes place, organic compounds decomposition takes place over there. Okay, then this is second technique, that is a DTA again, and DSC, how these two techniques can be used, and what are the applications of this one. And we have to give some different examples as well as some problems based around TGA, DTA, and DSC. Yeah, if you have any doubts, you can ask me. Hello? Hello?
Hello, sir. That is the unit number 4, thermal analysis, that is included newly in the syllabus for that semester. We discussed the principal theory and instrumentation, and lastly we discussed the problem based on these three techniques: TGA, DTA, DSC.
Simple problems based around TGA, DTA, and DC. That's why I'm saying that if you have provided some image how the decomposition of the compounds takes place over there, I think like that way. I think, because I'm not expert in this particular area.
Okay.
And there may be some repetition in DTA and DSC here.
Here same is a repetition.
Same is there. That's why. Please check in original syllabus. Please.
Yes.
Then lab course. Yeah, I think the syllabus of laboratory course 105, some part of organic chemistry is there, and it is related to preparation of some of the organic compounds by single step preparation. One stage preparation.
Yes, sir.
Like usually we are giving benzyl acetone formation from benzaldehyde. Okay, by using Claisen-Schmidt condensation reaction to the students, and it's easy practical. Within half an hour, we can perform this particular practical number 2. Okay, then third practical, Sandberg reaction. Hello,
sir. You are audible.
Yeah. Third practical is a preparation of parachlorotoluene from paratoluene. See, parachlorotoluene is again liquid, parachlorotoluene is solid, no doubt. Here we can take this one, what do you call, parachloroaniline 2,1,4-dichlorobenzene. That 1,4-dichlorobenzene is a solid one. And if solid compounds is coming, then we can purify by means of crystallization and we can take the melting point of that particular compound. Means, see, next time we will change this particular practical also. Yeah, as you are taking experience, you are experienced with paratoluene to parachlorotoluene. That is good and it's easy practical. Means the student will learn diazotization reaction and for later on trapping of that diazonium salt by means of CuCl. Okay, it leads to the chlorotoluene formation takes place. Then Cannizzaro reaction, you can take chlorobenzaldehyde or other some aromatic aldehydes also. And this with the help of aromatic electrophilic substitution reactions, this of para-nitroaniline, no doubt it's an easy one. Just the separation of ortho and para isomer is there by means of crystallization. Similarly for para-bromoaniline also. Yeah, this nitration directly we can carry out by means of nitrating mixture, and for bromination we can use a green chemistry approach, that is without using bromine in acetic acid we can use potassium bromide bromate method over here. Then ceramic acid by means of Perkin reaction if possible, because there is a ban on acetic anhydride, that's why usually it's a difficult task. Novel condensation, yeah, we can do novel condensation by taking different types of active methylene compounds like melonitrile, which is very much easier, melonitrile and aromatic aldehydes, or ethyl acetate or ethyl cyanoacetate. You can take any kind of Michael donor or active methylene compounds and reaction with different types of aromatic aldehydes. And finally, coumarin synthesis here is there by means of Pitchman condensation reaction of resveratrol with ethyl acetate in presence of few drops of sulfuric acid, which leads to the 4-methyl 7-hydroxy. 7-hydroxy 4-methyl coumarin formation takes place. This is the too many practicals are there. Yeah, but I think very few practicals, minimum practicals may be conducted at next semester. किती घेतो आपण, काही त्याचं लिमिट दिलेलं आहे का? हॅलो,
Sir, we have.
Yes.
येस सर बोला.
किती
एक 8 पर्यंत वगैरे.
या, कारण प्रॅक्टिकल सिंथेसिस कंपाऊंड्स दॅट्स
जेवढे पॉसिबल होतात तेवढे घेतो आम्ही.
okay. And the second one is estimations of formalin, calorific estimation of dyes, estimation of amino acids. Okay, this is the one of the. Then he could not say.
These are from analytical section.
Yeah, analytical chemistry section. Analysis of pharmaceutical tablets to verify Lamb's law and amount of the glucose solution parametrically and the value of. Okay. Yeah. With this discussion of this topic. काय विचारायचं?
हॅलो शिंपे सर.
यस मॅम.
अनालिटिकल केमिस्ट्रीचा पार्ट जो तुम्ही सांगितला, आम्हाला थोडस गायडन्स असा हवा की त्या मुलांना आम्ही प्रोजेक्ट साठी देताना टिपिकल अनालिटिकलचे काय प्रोजेक्ट असतात ते जर सांगितलं.
मॅडम परत एकदा बोला, तुम्ही आवाज क्लिअर येत नव्हता.
अनालिटिकलचे प्रोजेक्ट देताना काय द्यावेत असं तुम्हाला वाटतं?
यस, काय अपेक्षित आहे? यस. या युजली आपल्याकडे काय करतात ते सांगतो मी. आमच्याकडे अनालिटिकल केमिस्ट्री आहे, मागचे 10 वर्ष झालं. आणि अनालिटिकलच्या मुलांना आम्ही ज्या टॅबलेटचं अनालिसिस देतो, बाय केमिकल जे IPPP वापरून जसं आपण करतो तसंच ते एक. माझा आवाज क्लिअर येतोय का तुम्हाला?
हो थोडासा हे होतो सर.
हा काहीतरी आवाज दुसराच येतोय मला. येस. आणि दुसरं अनालिटिकल केमिस्ट्रीच्या मुलांना प्रोजेक्ट देताना जे काही मार्केटमध्ये अवेलेबल ड्रग्स आहेत त्या ड्रगचा अनालिसिस एक भाग आहे. दुसरं ज्या इंडस्ट्रीज आहेत मॅडम, इंडस्ट्रीमध्ये आता समजा पोल्युशन कंट्रोल बोर्ड इंडस्ट्री जे आहेत, MPCB जे म्हणतो आपण, किंवा एखाद्या इंडस्ट्रीमध्ये त्या मुलांना प्रोजेक्ट करण्यासाठी आम्ही पाठवतो. तिथं मग ETP प्लांट असेल, ETP प्लांट मध्ये कशा स्वरूपाचं अनालिसिस केलं जातं, तर त्याचा एक प्रोजेक्टच्या माध्यमातून देता येऊ शकतं आपल्याला. मग त्याच्यावरती तो प्रोजेक्ट लिहू शकतो, कारण तिथं ज्या मेथड ते वापरतात त्याच मेथड ऍज इट इज वापरून नाही, यांनी जे काही थेअरीमध्ये ज्या गोष्टी शिकलेल्या आहेत ते थोडंसं डोकं लावून तिथंही तो करू शकतो. दुसरं, आता जे काही वेगवेगळ्या फार्मा अनालिसिस म्हणजे फार्मास्युटिकल इंडस्ट्रीज ज्या आहेत, आता साताऱ्यासारख्या ठिकाणचं मला स्थिती माहिती नाही, पण ज्या काही फार्मा इंडस्ट्रीज असतील तिथं जाऊन तो विद्यार्थी QC किंवा QA मध्ये 1-1.5 महिन्याचा प्रोजेक्ट वर्क तो करू शकतो. आता आपल्याला डिपार्टमेंट लेवलला म्हणजे इन्स्टिट्यूट मध्ये जर द्यायचं झालं तर ऍज इट इज अनालिटिकल वर्क देणं फार अवघड जातं मॅडम. तुमचा प्रश्न एकदम व्हॅलिड आहे. त्यामुळं बऱ्यापैकी ज्या गोष्टी अनालिटिकल केमिस्ट्रीच्या मुलांनी शिकलेल्या आहेत त्याचा उपयोग करायचं म्हणलं की अवघड होतं. त्यासाठी मग कुठं तर मटेरियल प्रिपरेशन देणे, म्हणजे सिंथेसिस ऑफ सम मटेरियल्स, देअर कॅरेक्टरायझेशन बाय मीन्स ऑफ सेम टेम TGA, DTA, DSC, देन XPS, XRD, आणि ऍप्लिकेशन्स ऑफ दोज मटेरियल्स ऍज अ कॅटलिस्ट म्हणून तसाही प्रोजेक्ट देता येऊ शकतो असं मला वाटतं मॅडम. कारण मी ऑर्गॅनिकचा आहे त्याच्यामुळे माझे लिमिटेशन मी तेवढं सांगू शकतो.
डेफिनेटली सर.
हा, आणि कसं आहे, उद्या मुलांना अनालिटिकलचा जरी विद्यार्थी असला तरी त्या मुलाला थोडंफार सिंथेसिस आलंच पाहिजे, आणि सिंथेसिस केल्यानंतर त्याचं अनालिसिस करणं हे आलंच पाहिजे आहे.
Sir, we have the HPLC in Common Facility Center of our institute, but we don't have the limitation of standard. That's why we are facing also problem with that.
Yeah. That's a good one. पण मला असं म्हणायचं आहे की if you have HPLC, at least we can show to the students how HPLC can be used for the determination of percentage of some organic compounds. How we can determine the purity of organic compounds with the help of HPLC or GC. ओके, आता काय झालं, मागचे 1.5 वर्ष झालं आपल्या स्टडी टूर किंवा व्हिजिट्स ह्या बंद झालेल्या आहेत. अदरवाइज वी कॅन शो टू दी स्टुडंट्स सम प्रॅक्टिकली हाऊ HPLC, नॉट ओनली सिम्पल HPLC बट ऑल्सो RP-HPLC, रिव्हर्स HPLC ऑल्सो. तर याचा मग तिथं पोलार कंपाऊंड असेल, नॉन पोलार असेल, व्होलाटाईल, नॉन व्होलाटाईल असेल, तर त्याचा उपयोग करून कसा HPLC मध्ये उपयोग केला जातो आणि त्याची प्युरिटी चेक केली जाते हे पण आपण सांगू शकतो. येस, आय कॅन अंडरस्टँड देर आर लिमिटेशन्स ऑफ स्टँडर्ड्स ऑल्सो. आणि एक HPLC रन करायचं म्हणजे त्याला कमीत कमी 5,000 रुपयाचं सॉल्व्हंट लागतं. येस. Yes,
madam.
Yes, sir.
Question आहे का?
No, sir.
विचारू शकता काही जे सिलेबस, मलाही तेवढं जास्त अनालिटिकलचं माहिती नाही, पण जे काय माहिती आहे ते मी शेअर करतो.
तर ऍक्च्युली मुलांची डिमांड अनालिटिकलला खूप जास्त आहे.
Yes.
आणि त्यांना सोल्युशन प्रिपरेशन किंवा एस्टिमेशन वगैरे कडे जर ते त्यांना यायचं म्हटलं तर ते जरा ते नाखुश असतात.
बरोबर आहे.
काहीतरी करून सिंथेसिस करायचं आणि कॅरेक्टरायझेशन करायचं ही रुटीन प्रोसिजर झाली.
येस येस मॅडम. आता फॉर एक्झाम्पल समजा आपण जे रुटीन सॉल्व्हंट जे वापरतो, अल्कोहोल असेल, मिथेनॉल, इथेनॉल किंवा बेंझिन, टोल्युइन, हेक्सेन, इथानॅस्टेट असेल, ऍटलिस्ट त्या मुलांना त्या सॉल्व्हंट मध्ये असलेलं मॉइश्चर हे कसं डिटरमाइन करायचं, मॉइश्चर कंटेंट बाय मीन्स ऑफ कार्ल फिशर रिएजंट KFR. ऍटलिस्ट आपल्याकडे ते इन्स्ट्रुमेंट, छोटस इन्स्ट्रुमेंट आपल्याकडे असलं पाहिजे मॅडम.
हो असते. हो हो.
कार्ल फिशर असलं पाहिजे. पुन्हा हाऊ टू कॅलिब्रेशन ऑफ डिफरंट टाइप्स ऑफ इन्स्ट्रुमेंटेशन, कॅलिब्रेशन ते पण आलं पाहिजे. स्टँडर्डायझेशन ऑफ सम कंपाऊंड्स, इट मे बी इनऑर्गॅनिक कंपाऊंड्स, हाऊ टू स्टँडर्डाइज देट, सोल्युशन स्टँडर्डायझेशन त्या मुलांना स्वतः करता आलं पाहिजे. आज अनालिटिकल केमिस्ट्रीच्या म्हणजे डिमांड खूप आहे मॅडम. इंडस्ट्रीमध्ये अनालिटिकल केमिस्ट्रीला डिमांड प्रचंड आहे, पण त्या प्रमाणात जशी ट्रेनिंग पाहिजे तशी ट्रेनिंग त्या विद्यार्थ्याला मिळत नाही.
बरोबर आहे. तोच माझा प्रश्न तोच होता की अनालिटिक्स मधनं जाऊन पण त्या मुलांना बऱ्याचशा गोष्टींचं नॉलेज येत नाही.
येस 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 मी मान्य करतो, कारण जे स्पेशलायझेशन आहे त्या स्पेशलायझेशन मध्येच प्रोजेक्ट असले पाहिजेत, त्याच स्पेशलायझेशन मध्ये तो मुलगा ट्रेंड झाला पाहिजे, या मताचा मी पण आहे.
सगळ्यात जास्त स्किल तर अनालिटिकल मध्ये आलं पाहिजे.
मग त्याच्यासाठी आपल्याकडे इन्स्ट्रुमेंटेशन फॅसिलिटी तेवढी स्ट्रॉंग पाहिजे मॅडम. म्हणजे इव्हन तो मीटर जरी कॅलिब्रेशन करता आलं तरी खूप झालं मॅडम. हाऊ टू कॅलिब्रेट बॅलन्स, इथून सुरुवात. म्हणजे ब्युरेट आणि पिपेटचं कॅलिब्रेशन सुद्धा तेवढंच महत्वाचं आहे.
येस सर.
इव्हन आता म्हणजे पीएच मीटर मध्ये आपण जे टॅबलेट वापरतो, पीएच बफर 4 असेल 7 असेल, त्या टॅबलेट मध्ये कंपोजिशन काय आहे हे मुलांना माहिती असलं पाहिजे.
येस.
मग हे साधं कंपोजिशन काय आहे, इव्हन दो MSc PhD जरी झाले तरी माहिती नसतं बऱ्याचदा. येस. तर ह्या साध्या साध्या गोष्टी जर आपण त्या मुलांना शिकवल्या तर त्याच्यामध्ये इंटरेस्ट निर्माण होईल, आणि कॅलिब्रेशन म्हणा किंवा स्टँडर्डायझेशन म्हणा, या सगळ्या गोष्टी म्हणजे पीएच मीटर, स्पेक्ट्रोफ्लोरोमीटर, स्पेक्ट्रोमीटर, कंडक्टोमीटर, हे सुद्धा म्हणजे केमिकल मेथड्स ऑफ अनालिसिस वर आपण जास्तीत जास्त भर कसा देता येईल हे पण बघितलं पाहिजे.
म्हणजे फर्स्ट इयरच्या मुलांनी एवढं प्रॅक्टिकल, एवढा प्रोजेक्ट केला छोटासा कॅलिब्रेशनचा किंवा स्टँडर्डायझेशनचा, तरी पण त्यांना त्या सब्जेक्टचा इंटरेस्ट डेव्हलप होऊन ते सेकंड इयरला काहीतरी अजून चांगलं करू शकतील.
डेफिनेटली मी म्हणतो की कॅलिब्रेशन ऑफ बॅलन्स, कॅलिब्रेशन ऑफ पीएच मीटर, म्हणजे हे साध्या गोष्टी, आणि कॅलिब्रेशन आणि स्टँडर्डायझेशन या दोन गोष्टी जरी फर्स्ट सेमिस्टरला किंवा सेकंड सेमिस्टरला त्या मुलांनी शिकल्या तरी खूप झालं म्हणतो मी. काय बाकीचे तर प्रॅक्टिकल आहेतच, बाकीचे आहेतच, पण त्यापेक्षा त्यांची ओन आयडेंटिटी कशी निर्माण करता येईल हे पण आपण विचार केला पाहिजे. आता सांगितलं की वजन घ्यायला सांगितलं मुलांना, म्हणजे 253 मिलीग्राम वेट घ्यायचा आहे. मग तो विद्यार्थी असा विचार करतो 253च्या ऐवजी काय 270 घेतलं तर काय फरक पडतो. त्यापेक्षा अॅक्युरेसीचं महत्व सांगणं हे सगळ्यात महत्वाचं आहे मॅडम, अॅक्युरेसी. आणि तशा स्वरूपाचे बॅलन्स आपल्याकडे असणं, ते अॅक्युरेसी सगळ्यात महत्वाची. आता मी काय करतो, कधी कधी आम्ही प्रॅक्टिकल मध्ये आम्ही नॉन कंपाऊंड देतो, ऑर्गॅनिक कंपाऊंड, आणि मेल्टिंग पॉईंट घ्यायला सांगतो, सगळ्याला सारखाच देतो, पण देताना वेगवेगळ्या ह्याच्यात जर वायल मध्ये जर दिला ते मुलांना वाटतं वेगवेगळं आहे, पण आपण शेवटी एकच दिल्यावर राहतो. मग अॅक्युरेसी किती आहे त्या मुलांची लक्षात येते. आणि अनालिटिकलच्या मुलाकडून हेच अपेक्षित आहे.
बरोबर आहे सर. थँक्यू सर, थँक्यू व्हेरी मच. म्हणजे मला फक्त तुम्हाला हा प्रश्न विचारायचा होता, जेणेकरून आमच्याकडे नवीन जॉईन झालेली जी फॅकल्टी आहे त्यांना चटकन काय प्रोजेक्ट द्यावा असा प्रश्न पडू नये. अशा बऱ्याचशा गोष्टी आपल्याला खूप माहिती असतात, पण ज्या मुलांना माहिती नसतात ते आपण त्यांना प्रोजेक्ट म्हणून देऊ शकतो.
बरोबर,
छोटा
हो, छोटा देऊ शकतो ना आपण, छोटा देऊ शकतो. आता मी एका वर्षी एका मुलाला प्रोजेक्ट दिला होता मॅडम, आपल्याकडे IR आहे, बरोबर आहे, IR आहे. मी एका मुलाला प्रोजेक्ट दिला होता, एक 10 वेगवेगळ्या प्रकारचे कार्बोनिल कंपाऊंड दिले होते, आणि काय नाही IR फ्रिक्वेन्सी मेजर करायचं नाही, त्याचं अनालिसिस, त्याच्या स्ट्रक्चर पण प्रोव्हाइड केले.
बर.
आणि त्याच्यातनं इतकं तो आयआर मध्ये इतका परफेक्ट झाला की सांगता नसणार. म्हणजे साधा कीटोन असेल, अलिफॅटिक कीटोन, अरोमॅटिक कीटोन, अल्फा बीटा अनसॅच्युरेटेड कीटोन, सायक्लिक, असायक्लिक असे सिस्टीम वेगवेगळे एक 15 कीटोन दिले. आणि त्या कीटोन मध्ये असे काही सॅम्पल दिले की ज्याच्यामध्ये अल्कोहोल पण 10% आहे आणि त्याचा आयआर घ्यायला लावला. मग ते मिक्सचर असताना कसा येऊ शकतो आयआर असे.
छान. जेणेकरून त्याला ते थोडीशी अनालिसिसची हे झाली पाहिजे.
येस येस, थोडीशी अनालिसिसची प्रॅक्टिस झाली पाहिजे.
येस. गायकवाड सर कोण आहे पुढचं? घ्या.
वाघमारे मॅडम.
Thank you very much, sir, for your valuable guidance on syllabus. We will definitely incorporate your suggestions while teaching.
Yes,
Now,
thank you, one and all, because it's a difficult task to me to discuss the syllabus of organic chemistry as well as analytical chemistry. But I have tried my level best to give something to you.
okay. Thank you, sir.
And I'm always with you, all people. तरी मी आज मला काय म्हणतात ते एमपीएससी ची ड्युटी होती. मी 2 वाजता घरी पोहोचलो. आल्याबरोबर त्यांना फोन केला, म्हणला मी 3 वाजता बरोबर जॉईन होतो चव्हाण सरांना. आणि मला एमपीएससी ची ड्युटी हे माझ्या घरापासून 20 किलोमीटर अंतरावर होती. पण आपण हो म्हटलं नाही, त्यामुळे मग ते करणं गरजेचं होतं. मिसेस सर, नमस्ते सर.
नमस्कार नमस्कार सर.
तुम्ही दिलेली जबाबदारी पार पाडली आहे त्याबद्दल धन्यवाद.
सर निश्चितच आमचा पूर्ण विश्वास आहे.
ठीक आहे.
बरं का सर, आजचा सर आमचा हा दिस इज द 3rd डे ऑफ आवर एफडीपी प्रोग्राम. Yesterday we have FDP program on diploma and advanced diploma. Day before yesterday we have FDP program on revised syllabus of BSc part 1st, and today we have FDP program on this MSc part 1st syllabus. सकाळच्या सेशन मध्ये सर फिजिकल आणि इनऑर्गॅनिक मध्ये डेलेकर सरांनी अतिशय चांगलं मार्गदर्शन केलं सगळ्यांना. आणि तुमच्या दुपारच्या सेशन मध्ये सर काय सगळेजण अगदी आनंदी आहोत आम्ही. म्हणजे यू हॅव गिव्हन व्हेरी फ्रुटफुल इन्फॉर्मेशन. आणि आम्हाला किती डीप मध्ये आपण शिरलं पाहिजे एखाद्या विषयामध्ये हे तुम्ही ऑर्गॅनिकच्या बाबतीत तर सांगितलं सर. पण मला असं वाटत होतं की सरांना अनालिटिकलच्या बाबतीत म्हणजे एवढी डेप्थ तुमची ऑर्गॅनिक बरोबर जेवढी आहे तेवढीच अनालिटिकलची डेप्थ आहे सर. आम्हाला खूप आनंद होतो याबद्दल. तुम्ही अतिशय चांगल्या प्रकारचं अनालिटिकल सुद्धा आम्हाला एक्सप्लेनेशन चांगले. हा बोला ना सर.
सर मला सांगायला आनंद होतोय की मी इप्का लॅबोरेटरीज मध्ये 1 वर्ष क्यूसी आणि क्यूए मध्ये काम केलेलं आहे सर. क्वालिटी कंट्रोल.
अरे वा.
इप्का लॅबोरेटरी.
आणि त्यात दुसरं सर,
yes
even after having a duty of MPSC examination you have attended our session sir. आम्हाला खरंच we feel proud ना. म्हणजे आमचा मेन प्रॉब्लेम सर कुठे आहे, प्रोजेक्ट मध्ये थोडासा आम्हाला आणि आता ह्या पॅन्डेमिक सिच्युएशन मध्ये सर इंडस्ट्रीमध्ये मुलांना पाठवणं किंवा त्यांना घेणं आम्हाला खूपच यावर्षी हेक्टिक झालं होतं थोडस.
शक्यच नाही.
हा मग तो आम्हाला प्रोजेक्ट जरा आम्हाला यावर्षी थोडेस त्रासाचं झालेलं आहे. ऑफलाईन जर चालू झालं सगळं तर मग काय प्रॉब्लेम येणार नाही एवढे. इंडस्ट्रीमध्ये मुलांना जाता येतं, प्रोजेक्ट काहीतरी करता येतात. पण तरी सुद्धा तुम्ही अनालिटिकलच्या बद्दल सुद्धा भरपूर आम्हाला इन्फॉर्मेशन दिलेली आहे सर. आणि विभागाच्या वतीनं सर मी तुमचं आभार मानतो. हॅलो.
हा सर.
विभागाच्या वतीनं आणि वैयक्तिक माझ्या वतीनं मी आपले आभार मानतो सर.
धन्यवाद सर. धन्यवाद. आणि कधी आवाज द्या, मी सोबत आहे सर. कधीही.
निश्चित सर, आम्हाला तेवढी खात्री आहे तुमच्याबद्दल सर, निश्चितच.
ओके सर. ओके.
Now I
वाघमळे
request to
मॅडम.
Mr. PV. Now I request to Mr. PV Bise sir to conclude all sessions.
हॅलो,
Okay, sir.
येस.
वाघमळे मॅडम.
Directly.
Yes sir.
Okay.
Now I
हा,
request
गो टू वोट ऑफ थँक्स.
Gaikwad sir to express vote of.
Thank you, madam.
Okay.
It is my immense pleasure to give a vote of thanks on the occasion of third day of a faculty development program organized by the Department of Chemistry. Today, both the sessions are very fruitful for the discussion on the syllabus of MSc first semester first. I express my sincere vote of thanks for the second session resource person. It is not only a resource person, it is more than that of that, because the Professor Dr. B.B. Sinte sir, it is act like a ligand and we feel like we are the Lewis acid, that is the metal ions. Lots of information they have delivered, and only I accepting that as a metal ion get that. Okay, sir have discussed not only the organic chemistry syllabus, but they also discuss on the analytical chemistry syllabus also, and also discussing a point regarding to that of the project for the MSc students. Thank you, sir. Thank you very much. I also express my thanks to the coordinator, Dr. P.V. Chavan sir, and BO chairman, Dr. V.V. Sawant madam. I also express this thanks to Mr. P.V. Bise sir, here Department of Chemistry. And lastly, I express my sincere thanks to Principal Dr. B.T. Jadhav sir. Last but not least, our faculty taking efforts from that of the 3 days to attending that all the sessions. That's why we also thanks to all the faculty members of chemistry department for attending that third day of the faculty development program. And with the permission of head of the Department of Chemistry, Mr. P.V. Bise sir, all the today's sessions are over. Thank you.
Thank you, sir.
Thank you.
सर मीटिंग क्लोज करा.